Good morning. My name is Sana Arora, and I am a core committee member of IIT-VIT. I am pleased to see the enthusiasm of the audience and would like to welcome you all to our workshop, Level Up with Cloud, where we'll be discussing how to build and deploy and scale apps. We are glad to introduce our speaker for today's workshop, Mr. Dhruv Solankia. He is the founder of ToggleBytes One Technologies and has been a tech enthusiast for more than 10 years. He's closely working with several tech labs and incubation cells for helping startups with tech innovation. His venture at ToggleBytes helps companies to transform digitally. His company believes in mobility with agility. Sir, we are grateful to have you today. The platform is all yours.
Thank you, everyone, and thank you, Sana, for that lovely introduction. Good afternoon, guys. Here, basically, we are talking about leveling up with cloud computing, and I hope the session is informative as well as I can give something to you to go back and maybe try something on cloud as well. What I understand here is obviously that we have most of the viewers who are maybe looking at kickstarting their careers in cloud computing or maybe looking at leveling up what they know on the cloud side. So good afternoon again, and just a little introduction about cloud computing, a little few definitions and stuff I'll be starting with. It's an on-demand access via the internet to computing resources, applications, servers, data storage, development tools, networking capabilities, and more, which is hosted at a remote data center managed by a cloud service provider. A cloud service provider basically could be a Google Cloud or an Amazon Web Services or even Azure. Now, these are called cloud service providers, which are also called as CSP. The CSP makes these resources available for a monthly subscription fee or bills and builds them according to the usage. Now, comparing to the traditional on-premise IT hardware, usually the local clouds that we used to say or local servers that we used to say, um, now things are pretty much shifting towards the cloud, and there's a reason why. Because to have an on-premise IT hardware server and to maintain it, obviously there are a lot of higher IT costs that go into it. You have to manage. You have to have an IT team to basically manage the server. You have to ensure that the hardware works fine. You have to maintain the hardware and so on and so forth. So, which is why the IT costs were going quite high while they were maintaining it on premise. Here, what's done is that the CSP or the cloud service provider takes the headache of the servers, your data storage, your cloud computing, and the server capability, the CPU usage as well, and things like that. So, which is why cloud service providers, we saw a lot of organizations, even governments, shifting to cloud services because of this one sole major reason, which is also the IT cost. Also, maintenance is another reason why, because it really makes you capable of just focusing on your own business rather than maintaining your servers. So that's another thing. Obviously, there's improvement in the agility and the time to value. With cloud, the organization can start using enterprise applications in minutes. Instead of waiting weeks or months for IT to respond to a request, do a purchase, and configure supporting hardware, then install the software, cloud also lets you empower certain users, specifically developers and data scientists, to help themselves to software and support infrastructure. There's also there is very it's easy to scale and with a cost effective manner. Cloud service providers provides elasticity. Instead of purchasing excess capacity in advance that sits unused during slow periods, you can scale the capacity of a server up and down in response to spikes and dips in traffic. You can also take advantage of your cloud service provider's global network to spread your applications closer to users around the world. For example, if I'm sitting in India and I'm pinging a website which is sitting on in US server, I'm sure you all know that ping rate increases. So for example, for my request to go to that US server and to respond back is going to take much more time had the request gone to a India based server. So obviously it makes a huge difference when we are talking about cloud. These cloud providers, they provide mirroring solutions as well in different regions. So for example, if you're in India, we have one of the servers for AWS we have in Mumbai itself. The other one earlier was either Middle East or the Singapore cloud, where so what they do is, if I upload a website or my data on cloud, maybe on, let's say for example, on Amazon web servers. So when I upload it there, it basically mirrors my location, my data on which will obviously go. I'm sitting here in Mumbai, so it will basically upload in the Mumbai server. Also, what it will do is it will mirror my data or copy my data into multiple other servers in different regions of the world. So what happens is, one is I get data redundancy also. So if in case there is some due to some reason there is a failure in the server, in the Mumbai server, what happens is it takes the data which is mirrored on other locations straight away. The other thing is, if someone from maybe consider Africa is accessing my website or my data which is uploaded in Mumbai server, if there is a server near Africa, it will ping that particular server rather than coming all the way to Mumbai server and then getting the ping back. So that is what is the difference when we are talking about mirroring, and that is the real value of cloud computing as well. Now, cloud computing can basically go in different ways, and let me explain you with a little bit of understanding. So, we spoke a lot about what is cloud computing. I'm sure you all must have read, a few things about cloud computing as well, since you all are, interested in this particular topic. So, let me just basically give you an understanding. If you can go to the next slide, uh, you know if you've heard about cloud computing, you're already using cloud computing. To the biggest example, the biggest examples are Gmail. It is a sheer example of Gmail. How fast does it load? Does it load just because it's it's an efficient code? Not just that, it's basically cloud computing that is used completely here. The resources that are used for on cloud are, you can see that the kind of response that you get when you're refreshing on Gmail. It's why is it so fast? Why is it lightning speed? It's because they are using the potential of a cloud. Okay, so Gmail is one of the best examples of a cloud computing. Then you can use Google Drive. Google Drive is basically what? You are storing your data on Google Drive, which basically is again a cloud. Again, for other people who are not using any of these, I'm sure most of them would be using, but most of them would also, some of the other people would be also using either Netflix or Amazon Prime. Again, classic examples of cloud computing. We see how fast these videos are buffering on your phone, on your laptop or on your TV, wherever you are using it. Earlier, when we obviously you need a good data connection, there's no question about that. Talking 5 years or 7 years back, there was a lot of buffering which was happening while we were using maybe 2G or 3G. But now, with the advent of 4G, these cloud computing has gained a lot of importance, and we see applications all around us which are harnessing the potential of cloud computing. So yes, it's all around you. You just need to identify what is cloud computing, which are the applications that are using cloud computing. I think most of the applications that you might be using today are harnessing either cloud computing in some of the service models. Now there are various models in which cloud computing operates. Okay, but before that, before I delve into how what basically are these models, let's understand the entire flow of cloud computing. Can you go to the next slide, please? Okay, great. So here we have clients and servers. Now, again, just to make it very easy for you, all right. On the right hand side, you have client devices. Client devices is us, like we using any kind of applications like Netflix, Uber, Ola, anything, any kind of application that we are using, which basically is sending a request. Like for example, if you're using maybe Uber and you are looking for cab around your area, that is a request that you are sending to Uber's cloud, saying that I'm in this particular pin location. Please find me drivers around this location. So what it does actually behind the scenes is, Your application sends a request to the cloud network, which is from client device to the cloud network. Cloud network realizes, okay, this is the request to basically find a cab in this particular location, and this particular location is based in Mumbai. So let me do one thing. Let me check in Mumbai servers. So it goes to the Mumbai server. It checks what are there any drivers available, and then responds back to your client device, which is on your application. This is essentially how the cloud computing works. What is computing and what is cloud computing? Computing is just simply some kind of arithmetical logical operation that is happening on the server itself. Okay, so what this does is it basically finds in and around your location, maybe in a depends on their algorithm as well, maybe in a kilometer radius or 5 kilometer radius around your pin location. It finds if there are any drivers that are available and starts displaying that on your application, and then you choose, and you basically book a ride for yourself. So cloud computing, yes, this is computing. I told you something that is computing on the go, which is happening while you are in real time, is called cloud computing. So what the servers do is cloud computing, and what computing happens on your local laptop or PC is computing, where CPU is used. Okay, so exactly. So let's come back to this particular understanding of how the client and servers work. What is a client device? Client device is basically anything that you are using to access to access the cloud computing servers of the application you are using, either a website or a mobile app or anything that you are using. Maybe it could be a desktop based software as well. So yes, client devices, as I mentioned, is the applications or website. Servers are basically those are that are on cloud. There are three main players in cloud service, who are cloud service providers. One is Google Cloud, second is Amazon Web Services, which is AWS, and the third is Microsoft Azure. So these are the three main, basically, the service providers on cloud who are providing these services. We saw, we saw 2 years back, Microsoft Azure gaining a large, mandate from US government itself. So you can see that, that's that, because the reason is that they see the kind of security, or the transparency that the cloud gets you, because government data is obviously 100% confidential data that is going on cloud. So there will be a lot of people asking questions: is cloud secure, is cloud safe? I mean, yes and no. When was, if you talk about a physical IT service, a physical IT infrastructure, which was on your location, you can ask these people or these companies, how secure was your own server when it was on your own location. Accordingly, because they were completely dependent on their IT team to handle the security. Now what's happening is there are external, third parties like Amazon Web Services, Microsoft Azure, and Google Cloud, who are basically handling security for you, for your data, to make keep it confidential. So there's a lot of work that basically goes on behind securing your data, and that is what these companies are doing, and which is why there is a mass adoption that we are seeing here. So that is one reason why clouds are again used widely, especially by the governments, and obviously where the confidential data comes in. So we've seen a lot of companies moving to cloud as well. We saw Netflix moving to cloud a few years back. We saw Hotstar is obviously on cloud since quite some time, and stuff like that. So these are all confidential data for them. Their assets are money making for them. They can't afford to leak their own data or their videos to get leaked, and then maybe there's a huge piracy market which is waiting for them. So obviously the clouds are safe. Yes, we hear about hacks that are happening. It is going to happen any which ways. But the percentage of hacks that are happening are quite lesser than what we saw earlier. So yes, it is evolving as a technology, but yes, clouds are definitely safe. Moving to the next slide, let me explain you what are the different kind of servers. Can you move to the next slide, please? Yes. Okay, great. So here there are different kinds of servers that are basically used. One is email server, file server, web server. What are these basically? Let me explain. Um, uh, Web server are basically you use and you use to access a specific website, which is maybe facebook.com. So you send a protocol on HTTP or HTTPS. A web server is basically called, and it responds you back with the web page of maybe facebook.com or instagram.com, whatever you're using. Now that is a web server. A file server mainly is used to store files or rather data on the cloud storage. It could be a zip file, it could be a PDF, it could be anything else. So that is a file server. Now, every kind of server or every kind of request that you send is sent to the server on a specific port. That particular port is the port number that we identify with. So, for example, if you are accessing a website, it goes directly on port number 80 of a server. Very simple, nothing crazy. Servers are basically, to access a server, you have there's a gateway. The gateway is through a port. Every port has its own functionality. So that particular functionality is decided by the cloud where to basically send this particular request on which particular port. Like if I'm accessing a website, it should go on port number 80. If I'm accessing a file, it should go on the file server, which is on port number 445. If I am using an email server, like for example, if you are using Gmail, it goes on their server on port number 25. Okay, by the protocol which is called as SMTP, Simple Mail Transfer Protocol. Okay, so this is how your services are basically connected to the servers. Okay, moving to the next slide. um, yes, so how does application server use the database? This is how, again, it's through a port itself. So whatever you store, there's a computing that happens on the server, which is an application server. Let's go back to the example of Uber service. So when you are using an Uber application, it's obviously running. It will hit the application server. Then what it will do is it will you asked for a driver around you. So what it will do is it will hit the database server where the data of the available drivers would be stored. They access that particular information, fetch it from there, get it on the application server, and then the application server gives it back to your application mobile app from where you are sending the request. But this is how the application servers are connected to the database as well. All right. So yes, there is a question which has come in before we move to the next slide. How do you decide which cloud computing services to use for a given app development project, and what criteria should you use? All right. Again, app development project, now it completely depends on your application. Honestly, it's not something which you can say this particular, any kind of application can use this particular server. Yes, there are a few answers to that. You can maybe go for a VPS KVM machine, uh, which is a cloud, which is one of the cloud servers as well. You can maybe go for lambda functions on your AWS to handle the kind of data that is flowing through those functions. You can do the computing itself. Maybe you can use load balancers and stuff like that, but there is no one size fit answer to this particular question. Where an app development project of a scale, like for example, if you're using a Canva application, okay, the Canva application would be using so many services, so many servers as well, that you can't just say, and that is where a solution architect comes into the picture. So yes, you have to first identify what kind of functions that are going to work on your application, what are the features of the application, and depending on the features, what kind of servers do you need will be decided, and that's where a solution architect can help you. But before that, the scope needs to be defined and to be understood. There's another question which has come in, which is what is the scope of cloud gaming in the future? There is obviously cloud gaming is has picked up quite aggressively since last 5 years at least. I know that there is a Steam service that we see, which is obviously a kind of a cloud gaming. It is just, there is huge scope. Obviously, with blockchain also entering, having its application into cloud, I mean gaming, uh, it is going to have a mass adoption. So yes, it's going to be crazy future for gaming industry, and cloud gaming is the way forward. I mean, going back to local gaming, local PC gaming. For sure, there's a scope. So yeah, let's move on to the next slide. Let me explain you what are the benefits. I think I've already touched base upon some of these benefits, but let me just explain again. So on cloud, obviously we pay on demand. So it's basically not that, if you, for example, if you have bought a 500 GB server with 4 GB RAM and with a CPU of maybe i7. All right. Um, Now, if you are using maybe around only 100 GB out of 500 GB that you've used, had it been a physical IT server on your premise, you would have, even if you've not used 400 GB, you would still maintain or pay for 500 GB. So that is where the cloud comes into the picture, but then you pay on demand. So if I'm using only 100 GB, I will pay only for 100 GB. Although I do have an option of scaling it up to 500 GB, because if the traffic increases, then obviously I'll need more storage. So, which is why clouds are more beneficial when you're talking about scaling up. But however, you pay for what you use rather than you pay for what you expect to use. Yes, there is, apart from that, cloud storage. I explained you the mirroring concept, redundancy of the data, that it stores the data on multiple locations on multiple servers. So if in case one of the server goes down, then obviously there's a your data is still there on some other servers where it's mirrored or copied. um, so also it offers much more better security, because we see there are dedicated resources, dedicated developers working to secure your cloud network. So yes, it does offer a much better security than what you would have otherwise had on your on-premise IT hardware. In case of failure, data recovery is faster, as I mentioned earlier, and obviously maintenance is off your list. And this was one of the major nightmares for companies to operate as well. Maintenance is one of their biggest headaches when they are a tech based or a data driven company. So yes, it's off your list, and which is why that's one of the bigger benefits of cloud server. Let's move to the next slide, and we'll understand how these work as a service model. So there are various service models in which these cloud computing works. All right, one is IaaS, PaaS, SaaS. I'm sure you all must have heard about the last one, which is SaaS. SaaS. Uh, PaaS is a platform-based service model. Then we have IaaS, which is infrastructure. So let me explain you one by one what this means and what it is. IaaS is infrastructure used especially for IT administrators for data storage and maintenance. This means that there's an infrastructure that is created for you by a service provider, which basically means that you can store your data and you can basically access your data, which usually is done by an IT administrator. There is no application to it. There's a basic application like a file explorer that we use normally, and that's about it. Otherwise, this is called an infrastructure as a service. Then we have platform as a service. Here, basically, you deploy software applications on cloud. I mean, let's go back and understand. I'm sure some of you might have used Heroku, or some of you must have used Remix editor online on cloud, or some of you must have used W3 schools to compile, or to run one of your code that you are testing. Now, what that is basically is kind of a part of a kind of a platform as a service where you're deploying a software application. The software is a script, a small script. All right, it could be a huge script also, which could be thousands of files. So depends on that, but it's obviously a platform which is given to you as a service, maybe for free or on or by at a cost to you, but obviously it's a platform you are using as a service. SaaS, I'm sure you all know Netflix and Prime Video, and there are softwares like you can talk about a software like maybe. Uh, there's this software I was using, which was, I forgot the name. Hootsuite, which basically is a software as a service for scheduling your social media messages or post that you want to post. So that's a software as a service. So I mean, which obviously they charge you something for using their software, but obviously you can't deploy your software there. What the software that they have on the platform, you need to use that for as a service. You can't deploy your own software and say that okay, I want to use it in this way. No, so that's the rigidity, and that is why it's called SaaS, software as a service platform. You can deploy your own software. They give you the infrastructure. They give you the tools to basically deploy your own software like Heroku, and then basically you can use it. That's how it is. So yes, these are the different service models on which this cloud computing happens. I hope everyone is following. If not, just do a little bit of research on IAS, PAS, or ask relevant questions. If I can, I will definitely answer. All right. I think moving on to the next slide, there is cloud computing careers that I want to touch base upon. I think most of you might have these questions that what are these different career options that we have. So, as I spoke earlier, there is a solutions architect, there's a cloud architect, there's a sales development representative, account managers, cloud support engineers. Let me explain you one by one what each one does. So, I mean, if you are in getting into cloud computing and taking it as a career, then eventually you'll definitely start from being a cloud support engineer. Maybe before that, maybe an intern, then maybe cloud support engineer, and then moving up the rank, being an account manager to a cloud architect to a solutions architect. There could be some skips here and stuff like that. There's no one size fit mechanism here of how do you proceed, but generally this is what we've seen, and this is just to give you an idea. This is not a blueprint of your career. Please note that very well. All right. So what does each role mean? Obviously, these roles can change from company to company. The names can change, the description or the actual work will remain the same. So please ensure that you read the job description before you say that I'm uh, maybe a cloud architect or maybe a cloud support engineer. Look at what they are talking. Look at what your day to day tasks would be. How would your daily implementation would be like? What would your day look like? Learn that first, and then because there are many fancy terms also used, and there are very straightforward terms also used. Specifically, you will find something like this which is used generally in this space. So yes, let's start with a cloud support engineer. So what a cloud support engineer means is, when you go on, if you have any kind of issues on your cloud or on your application, you normally go on the support and start talking on the chat to a technical person, and that person gives you a very clear understanding of how to proceed. That person out there could be called as a cloud support engineer, who's basically an on-demand technical support for the client. Now, this is not something which basically is it's not an easy job. Trust me, guys. It sounds that it's just a support, but it's not just a support. You need to know every damn thing about the platform. Number one, if you are an AWS cloud support engineer, you need to know shit about AWS, cloud a lot. So yes, it starts from there for sure, but you need to know quite a lot of things. You need to undergo a lot of training before you become a cloud support engineer. So because the kind of support that you can get from a client or a customer, and because these are paid customers, all right, they want the solutions really really fast. Like for example, AWS does not give a cloud support engineer on demand for someone who's using a free tier service. It gives only for those who have basically taken a paid plan or a paid service that they are using, and only those get a technical support on demand. So just and when there's someone who comes on the support and asks for help, they really want it fast. And for you to deliver faster to the queries that you get from a customers as a cloud support engineer, you need to know your stuff really really well before you are sitting on that particular chair and giving assistance to giving cloud support, technical support. So yes, of course, you start as a cloud engineer. then becomes an account manager. Account manager is basically someone who handles clients. Like for example, if we are working with Uber, let's use our classic example that we've been using since quite some time. If we are going and if we are in Uber and just for example, if Uber is using Amazon Web Services as their cloud service provider, so Amazon Cloud provides gives Uber an account manager who basically ensures that Uber is all the time happy and basically is looking any kind of queries that Uber might have with regards to the cloud. They can have one point of contact who can answer these queries. Obviously, account managers are not completely technical. All right, their main work is to grow the account of the client and maintain the relationship with the client. So they're not highly technical individuals as such. Yes, they know technical aspects of a server, but again, they are not someone who would sit down and code in case things go wrong, in case the code breaks or something like that. So account managers are the ones who basically are the bridge between the solutions architect and cloud support engineer and the client. They are the bridge between the client and the technical team, just for your reference. All right, so account managers are those. They have technical knowledge. All right, so you could look at maybe account managerial role as well, because that is something. If you are someone who is quite outgoing and wants to basically and knows how to talk to a client, or you want to basically ensure you know you, you know how to upsell or cross sell services, go for an account managerial role. It's live up to your strengths rather than trying to be a part of the race that you are looking to have here. Next is sales development representative. Very straightforward. They ensure that the sales are done. They are given targets. Some companies give sales representatives compensation in terms of commission as well, which could be incentivized based on the sales that they get out to the company. And somewhere, most of the places you can find a base salary with incentives for the kind of sales that they bring on. um, then we have cloud architect. Very important. Eventually you will reach this particular stage where you're called a cloud architect, where they basically know how the customers implement the solution, and they define long term strategy for the customer. And these strategies are basically only for cloud, okay, not for their business. So these they define long term cloud strategy. Is that you know in most of the corporates, then when you work, you would find that there is a 12 months to 18 months of strategy that is already in place. And this is where a cloud architect comes into the picture, where he says that maybe after reaching a specific milestone, we use this particular another functionality of a cloud as well, and things like that. So there are various milestones at which they basically define how the implementation of the solution should work. So that's what a cloud architect does. Solution architects is pretty much a tech advisor for customer. So understand that a solutions architect could also be called a customer engineer. Okay, wherein they basically work as a virtual tech lead with the corporate. And basically they are the ones who understand how the servers work and how easy or faster they can deploy the solution that the client is looking to go live with. All right. So and obviously what happens is account managers are the ones who get solutions architect, cloud architects, and engineers on the same panel, or on the same page when there's a service required by a client. All right, so these are the careers that go with cloud computing. Obviously there could be much more. These are generalized, and these are some career options in cloud computing that we see normally and most of the times. There could be many others. There are, as I mentioned earlier, there are fancy names. There are many other kind of careers also that have come up. Um, so yes, for sure, there could be careers in other type of career options in cloud computing as well. But these are the main ones that you should be eyeing for, and which you can obviously play according to your strengths. Um, yes, I think there's a question. What are some challenges that developers face when integrating cloud computing into their app development process? Yes, there are a lot of challenges that they face in cloud computing, especially when we are talking about how to optimize the load, or if in case like for example, if your website or application is having a traffic of maybe 1,000 per minute, 1,000 pings per minute, for example, and if your company is looking to do a marketing campaign, and you are anticipating it might go to maybe 5,000 per minute, is your cloud application capable enough to scale to that level to respond to 5,000 per minute requests? That is one of the things that you need to look at as a developer, to do a load testing as well. So that is one of the major reasons what we've seen people go for cloud is because they want to ensure that at any point of time, if the traffic increases, then what is anticipated, like if we are anticipating, in our example, we anticipated from 1,000 traffic, 1,000 pings per minute, requests per minute, we anticipated maybe 5,000, but maybe the marketing campaign went viral, now we are maybe getting 15 to 20,000 per minute. Is your server capable to do that? Is your code capable to do that? Leave the server. Before that, your code should be able to respond to the request, right? Your code should be efficient enough to do a 20,000. So, but yes, it goes hand in hand. If your code is capable, is the server capable? If a server is capable, then yes, it won't crash. If the server is not capable, it will crash. However, if the server is capable and your code is not capable, again it will crash. Your application will crash anyway. All right. So these are the major challenges which we would always need to find a middle ground, or we need to bridge the issue here, which is basically the ping rate, or how fast your code can respond or the server can respond. So yes, I hope I've answered your question. All right. So moving on to the next slide, Kitna milega. Obviously, everything comes down to that. We want to know how much basically you make as a cloud computing, and this is an average that I'm talking about. There are individuals I've seen that are making maybe 45 lakhs annum as well. Individuals who have started with maybe 5 lakhs moved on to 40 50 lakh per annum, and maybe heading to 80 lakhs as well. Depends on the organization, the kind of work that you do, the kind of exposure that you have, what kind of implementations you've done and stuff like that. But yes, on an average, this is the um, middle mid-level cloud computing professional who would make around 20 to 30 lakhs. And yes, of course, this is an average CTC. So yes, you're going good. If you're looking at cloud computing as a career, start now. What I would request you all is to take maybe an Azure session, or go for AWS, and or Google Cloud also, whatever you are comfortable with or what you think. For now, I mean, if you have to look at go for don't be biased towards a specific kind of server, because you never know what your career might shape out to be. You would need maybe a Google Cloud as well for the next 2 years, then maybe an Amazon Web Service as well, and whatnot. Or there could be a company using a hybrid platform. So go for the best ones. Currently, be going with the best. Azure is doing best right now, um, followed with AWS, kind of a tie tie there, and then there's Google Cloud. Obviously, Google Cloud is catching up very well now, but again, this is what we've seen. So yes, if you have any questions, I think we can open the this particular session for Q&A maybe.
Thank you so much, sir, for this insightful session. We will begin with the Q&A now. I'll read out the first question. How can developers ensure that their apps are secure when using cloud computing services?
Oh yes. That's a very relevant question, and which is why if you take a course on AWS or Google Cloud, you'll find a way to basically ensure that your application communicates with the server in a secured manner. There are various hash keys and there are various protocols that they are using to ensure the security is up to the mark. So yes, it is a part of the consideration while you are creating a server on either AWS or Google Cloud or Azure, whatever you're using. They already are taking care of the security for your application, either a web application or a mobile application or a software, as I mentioned earlier. So yes,
Okay,
it's
moving
already
on to the
covered.
next question. How
Yeah.
can developers best collaborate and work together when using cloud computing services to build complex applications?
How can developers best collaborate? Okay. Um, I, I mean, yes, you. I mean, the question is kind of not very straightforward. Let me try to understand the question. The developers can collaborate with each other, and I mean, the collaboration really happens at the code level. On the cloud computing service level, there's no collaboration as such, unless you are working in a team and then you are collaborating. That's a different ball game. Yes, building complex applications. Yes, you do need a lot of team members working together towards building a complex solution, which is on a cloud computing server. So I mean, but individual has to look at their own way of collaborating with their team members for cloud computing.
Okay, moving next one. How has cloud computing changed the way we approach app development and what benefits does it offer over traditional methods?
Okay, good question actually, because um, earlier what used to happen is it was a hassle, as I mentioned, to have a on-premise IT hardware, which basically you're calling as a server, and then those are the servers which were obviously now today. Just imagine you are, suppose you are Canva. You just started, you just made your application live. I'm sure you must have used Canva, which is why I'm using this particular example. So when you're using Canva to build a graphic design, and if you've just started out as Canva company, this is month number one for you, and you're looking at a global level from day one. You can't have IT hardware servers of yours on various locations globally, and that is where cloud computing comes into the picture, because you don't want your customers to wait before they create a design. You see how fast it works, right? The Canva application, it's just like on click of a button you get all the design templates, you start typing it. We are taking it very lightly, but it took a lot of time for us to reach this particular level. The kind of applications that we are using, which are feather touch fast, it has taken a lot of time. In fact, just if someone must have used the application 7 years back, would have realized how slow they were. Even if you talk about maybe a course learning application like Udemy, it never worked fast in India. It had worst ping rates in India. But today, when we use Udemy to learn any course, it's the course buffers almost instantaneously. Obviously, we've gone up with the bandwidth of the internet that we use. Also, the speeds have has gone faster as well. No doubt about that. But yes, it's not just about the speed; it's about the cloud server also, which is responding to your request. So yes, your application does have a huge benefit when we talk about cloud computing, because it enables you to have a global outlook from day zero.
The next one is how do you balance the cost of using cloud computing services with the benefits they provide to your app development process?
That's where an expert comes into the picture, and that's where a cloud architect or a solutions architect comes into the picture, because they understand where the costing will go high, which particular application to use, uh, you know what kind of, excuse me, what kind of infrastructure to use to ensure the costs are controlled as well, and basically it also serves the purpose of the application. So It's again not a direct an answer which can be given directly, but it's a play of maybe there are many things you need to balance. Yes, to answer your question a little bit more in depth, there could be load balancers that you can install on your for your application on cloud, obviously, which can ensure that there is a little benefit with respect to the cost that is given to you when there are peak of traffic, or maybe dip in the traffic. So yes,
Okay,
that's it.
moving on to the next one. What impact do you think cloud computing will have on the future of app development, and how do you see this technology evolving over time?
Okay, to answer that question, Kashish, I think we are already seeing the impact. Today, whatever you're using, I mean, the applications that you're using are already on cloud computing. Of course, the future is the AI as well, which basically uses a lot of cloud computing. I think we also OpenAI's Chat GPT. You see the kind of impact that has, and you're using from India, you're using from Africa, from Australia, you're getting the same kind of response because it's based on cloud server as well. It's using cloud computing to another level. So yes, we are seeing the impact. In fact, most of the applications that you will see are on cloud. Governments are moving to cloud. Imagine that government, most conservative institution, is going on cloud. So yes, it is the future and it is evolving always. We've just started with cloud computing since last 3 years. We've seen 3 or 5, actually more than that. We are seeing a lot of adoption, but of course, is the future and it will just keep evolving with time.
All right, sir. What technologies and strategies do you use to ensure zero downtime and no data loss? And how do you test and validate the resiliency and recoverability of the system under various failure scenarios?
Okay, lot of questions under one question, but let me answer part by part. Okay, so ensuring zero downtime. Yes, most of the cloud providers, they ensure almost zero, but it could be 99.9% and things like that. 100% is rarely seen. Of course, you won't find that kind of data loss because that is the beauty of having a cloud service provider, where they copy your data on different locations, server locations. So you don't usually see a data loss happening on a cloud unless and until there is a huge hack that happens wherein the hacker corrupts your data and stuff like that. That's one way only where your data loss can happen. Otherwise, in straightforward manner, your data loss won't happen. Apart from that, how do you test and validate resilience and recoverability of the system? Um, there's no specific way you can test you can test resiliency by maybe doing load testing and maybe A/B testing also, and concurrent testing. By that you can see whether your system is able to handle that kind of traffic and in concurrent manner and things like that. Recoverability of the system, again, it's from what are you recovering? Are you recovering from a straightforward deletion, or are you recovering from maybe what you can say, are you recovering from a hack? So that's basically what you need to understand. So yes, there could be recoverability is never a question on cloud because your data is always, you can back up your data as well along with that, along with testing your resiliency. So yeah, I think that's about it.
Okay, thank you, sir, for answering that. Devansh just asked, can you explain PaaS, the platform?
Okay, PaaS is basically a complete development and deployment environment in the cloud. Okay, complete development and deployment environment in the cloud with resources that enable you to deliver everything from simple cloud-based apps to sophisticated cloud-enabled enterprise apps. What that means is basically, if I mean, have you used Devans? Have you used W3 schools? If you've used W3 schools, to basically test your maybe HTML or CSS, it's a platform. all right, where you are deploying your code, even if it is a small script, one line script, but still it is a code which basically it is a platform where your code is getting compiled and run real time. Okay, so that's what pass is all about. This is a very small example I'm giving you, but we are talking about applications like Heroku, which have basically given that kind of platform to MNCs to deploy their software application. And why people use Heroku is to have another abstraction layer. You go from one location to another, one laptop to another. You don't want to basically every single time do a complete development environment setup done. You want to just log on to the your Heroku and start coding, start the development, and that is what a pass is. So yeah, I hope I answered your question, Devansh.
All right, sir. Thank you so much for answering all queries. It was a very due to the time constraints, we won't be able to take any further questions. Apologies on our behalf. Uh, Thank you so much, sir. Reached the culmination of today's workshop. And once again, I would like to thank you for your time and knowledge. This was a really good learning experience. Thank you so much, sir.
Thank you so much for having me. It was great to talk to the audience here, and I can see the kind of enthusiasm that these people are bringing in for learning cloud computing. I would really like to wish them all the best with their careers. If someone is starting out on cloud computing, please go full on, all in, go full throttle with cloud computing, because that is the future. And if that is your inclination, then please go for it without thinking twice. All right, all the best to you guys, and do a lot of courses on cloud computing. There's lots to learn. Keep doing it. All right. If you have any questions, you can reach me out on LinkedIn. My name is Dhruv Solankia. You can definitely ping me there, and yeah, I think that's all. Thank you,
Thank
Sana.
you.
Yeah, take care.